Okay, so the first equation is f of x is equal to x, which is a linear function. So the domain is from negative infinity to infinity, and the range is negative infinity to infinity.
The symmetry is odd. There is no boundedness.
It's a linear function, so it doesn't have any asymptotes, and the discontinuity is continuous because you can draw the line without lifting your thumb.
The line is increasing from negative infinity to infinity, and there is no extrema.
The second parent function is f of x is equal to x squared, which is a quadratic function. The domain is negative infinity to 0, bracket, and then the u, and bracket 0 to infinity. The range is 0 with a bracket to infinity.
The symmetry is even. It is bounded below.
It has no asymptotes and again is continuous.
The line increases from 0 to infinity and decreases from negative infinity to 0. The extrema has a local and absolute minimum of 0 at 0.
Parent function number 3 is the cubic function, and its equation is f of x equals x cubed. The domain and range are both parentheses, negative infinity, infinity, parentheses.
The symmetry is odd because when you flip the first quadrant over the x and y axis, it overlaps the part of the function in the third quadrant. There is no boundedness.
There are no asymptotes and the function is continuous.
The function is increasing from negative infinity to infinity, and there's no extrema.
Okay, number 4 is the inverse linear function, or the reciprocal function, or the rational function. And the equation is f of x equals 1 over x.
2 points on the graph is 1, 1, and -1, -1.
So to find the domain, you have to look at the equation first, and there's an x in the denominator, so x can't equal 0. And 0 is the only value that x can't equal, so the domain can go from negative infinity to 0, not including 0, and from 0 to infinity. And you can find the range by just looking at the graph and seeing that all of the y values are possible.
For symmetry, the function is symmetrical in relation to the origin, therefore the function is odd. This can be proven algebraically by substituting negative x for x, and then the entire function becomes negative. For boundedness, the graph continues infinitely above and below, so it is unbounded.
For the vertical asymptote, since x is in the denominator, you set it equal to 0. For the horizontal asymptote, you look at the degrees, and since the degree of the numerator is smaller than the denominator, you set it equal to 0 as well. For discontinuity, it's non-removable because there's no hole, and it's infinite discontinuity because there's infinite distance from x equals 0. Therefore, it's a non-removable infinite discontinuity.
If you read the graph from left to right, you can see it decreases from negative infinity to infinity, and since there is no local minimums or maximums, there is no extrema.
Parent function number 5 is the square root function, and its equation is f of x equals square root of x. The domain and range are both bracket 0 to infinity, parentheses.
There's no symmetry in bounded below.
There are no asymptotes and the function is continuous.
The function increases starting at 0 and goes to infinity, and the extrema is an absolute minimum of y equals 0 at x equals 0.
Okay, so we had the exponential function of f of x equals b to the x power. We have two graphs, one that shows where b is greater than 1, which is represented by 2 to the power of x, And the other shows where b is less than 1, and it's represented by 0.5 to the x power. When b is greater than 1, the graph increases, but when b is less than 1, the graph decreases. We also have no extrema.
The graphs are not symmetrical when analyzed separately, though they both have the y-intercept of 1. And there are no vertical asymptotes, but there's a horizontal asymptote of y equals 0.
Since there is an asymptote on the x-axis, the graph is bounded below. Since there is no break in the graph is continuous. The domain is all real numbers from negative infinity to positive infinity. The range is all real numbers greater than 0, not including 0.
This is a natural logarithm. The parent function is f of x equals log base b of x. There is no symmetry because it doesn't reflect over any axes.
The purple dotted line represents the vertical asymptote at x equals 0. The domain is 0 to infinity, not including 0. The range is all real numbers.
This function is not bounded and it is continuous, and it increases from 0 to infinity, not including 0. There are no extrema.
This is an absolute value function. The parent function is f of x equals the absolute value of x. The symmetry is even because it reflects over the y-axis.
The graph is in the shape of a V, with the bottom of the graph at the origin. There are no asymptotes and no discontinuities. The domain is all real numbers, and the range is 0 to infinity, including 0.
It's bounded below, and it decreases from negative infinity to 0, including 0, and it increases from 0 to infinity, including 0. There is an absolute minimum of 0 at x equals 0.
We have the greatest integer function. It is also known as the step function and the floor function. There is no symmetry and the equation is not bounded.
There are no asymptotes in this function, and the discontinuity is jump discontinuity at every integer.
This function is constant at each interval and has no extrema.
The domain goes from negative infinity to infinity, but the range is the set of all integers, meaning it can only be the whole numbers with no decimals.
This is the logistic function. The equation is f of x equals 1 over 1 plus e to the negative x. The domain is negative infinity to infinity, and the range is 0 to 1, not including 0, or not including 1.
The symmetry is neither even nor odd and is bounded above and below.
The asymptotes are y equals 0, which is also known as the x-axis, and y equals 1. There aren't any discontinuities, which means it is continuous.
The function is increasing from negative infinity to infinity, and there are no extrema.
Function 11 is the sine function, and the equation is y equals the sine of x.
The range is from negative 1 to 1, and the domain is negative infinity to infinity.
This function has odd symmetry and is bounded.
It is continuous and has an absolute maximum of 1 at pi over 2 plus 2 pi k, where k is in the element of all real integers, or all integers, and an absolute minimum of negative 1 at pi over 2 plus 2 pi k, where k is in the element of all integers.
Number 12 is the cosine function, y equals cosine of x.
The domain is from negative infinity to infinity, and the range is from negative 1 to 1. This function has symmetry with respect to the y-axis and is bounded with no asymptotes.
The graph is continuous and has an absolute maximum of 1 at 0 plus 2 pi k, where k is in the element of all integers, and an absolute minimum of negative 1 at pi plus 2 pi k, where k is in the element of all integers.